Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video, another video in our series of videos dealing with hypothesis testing, is going to test the significance of a sample kurtosis, okay? Or it's going to test the significance of the kurtosis associated with a particular sample. Now I have got some sample data here, but maybe just keep in mind that we've actually calculated the kurtosis of a group frequency distribution in a previous video. That video can be found in the playlist under group frequency distributions. And from that particular video, we had a sample size of size 50. Okay, that was the sum of our frequencies. And we calculated its kurtosis to be equal to minus 0.3063. So I had kurtosis that was relatively flat compared to a normal distribution, if that makes sense. Now, this particular calculation that we performed was based off a particular statistic. I'll just write it down. We're not actually going to do the calculation again, but the statistic was K was equal to the sample size times the sample size plus 1. Divided by the sample size minus 1 times the sample size minus 2 times the sample size minus 3. And in the video we did this particular calculation times the sum of the frequencies times the x's minus the x bars raised to the power of 4, all divided by the standard deviation, the sample standard deviation raised to the power of 4. And what we took away from that was it was 3 times the sample size minus 1, which needed to be squared, which needed to be divided by the sample size minus 2 times the sample size minus 3. Okay, just keep that in mind that was the formula that we used. We applied it to a group frequency distribution. We knew the sample size, we calculated the mean of the distribution and standard deviation, and so from this particular formula we got the kurtosis value, which was equal to minus 0.3063. Just to keep in mind that based off this particular statistic, if we fed in a distribution that was normal into this particular calculation, we would get a kurtosis of 0. Albeit, keep in mind that the kurtosis by definition of a normal distribution is actually in around 3. But this particular modification here actually transforms it so that we're baselining off 0. So a kurtosis value that's greater than 0 would be indicative of a leptokurtotic distribution. That's a distribution that's peaked relative to a normal distribution. A kurtosis that's negative would be indicative of a platykurtotic distribution. That's a distribution that's quite flat relative to a normal distribution. And in this case, we have a negative kurtosis. So what we want to do is we want to test the significance of this. I mean, how confident are we that this particular distribution is in fact platykurtotic? Okay, and to do that, we're going to need two things. We're going to need a standard error. We'll need a standard error for kurtosis, and we have a formula for that. The standard error for our kurtosis. Okay, the standard error formula is still quite simple. It uses the sample size. It's the standard error for the kurtosis is equal to 24 times the sample size minus 1 squared divided by the sample size minus 2 times the sample size minus 3 times the sample size plus 5 times the sample size plus 3, and it's the square root of this particular value here. Don't be intimidated by that. It's just a couple of multiplications, a division, and a square root. If you're interested in where that formula came from, I would recommend having a look at non-parametric statistics for non-statisticians, a step-by-step approach, and that's by Corder and Foreman, and that's published by Wiley. Okay, this particular standard error formula is actually in there, albeit it doesn't give you a proof of where it comes from, but it does present the particular formula and an example of how to apply it. So once we know the standard error, then we can actually calculate the appropriate test statistic. The test statistic is a Z statistic. Okay, so our appropriate test statistic is going to be Z of, with respect to the Z statistic or the Z score for our kurtosis, is going to be our evidence, the kurtosis of our sample, minus where we believe it should be. Okay, we're baselining off a distribution that has 0 kurtosis, or a distribution that's normal. Okay, 0 coming from this particular formula here, and that needs to be divided by the standard error of our kurtosis. Okay, so we've got everything really to do this particular test. Okay, we have the sample size and we know our sample kurtosis, so we can calculate the standard error quite quickly, and we can also calculate this particular test statistic, okay, which is a measure of how far our distribution is, our evidence is, away from where we believe it should be. Okay, so let's do the hypothesis test. Once again, this is a 5-step process. Our hypothesis test itself. Okay. Well, there's a null position. The first position, the null hypothesis. Sorry,